Okay, so that was all about the image sensors, CCD image sensor, CMOS image sensor, and TDI sensors. Next point, what we are going to cover is on the camera type. This is very important topic because this is the actual hardware type wherein we'll be having those uh, different types of cameras as line scan cameras or area scan cameras. So machine vision basically uses these two different camera types. The first is the line scan and the other is the area scan. So talking about line scan, what we have studied in our previous points or in image sensors is that line scan cameras capture the image as a single row of pixels, right? Most of the times you have seen in any shopping mall, there are barcode readers, right? There are vertical lines of different width. The moment we scan a light in a horizontal way, it reads away, right? So that's how those vertical line bits are being identified with a particular number, and automatically the moment we scan it in a single line, so that's only one row of pixel holding some identities, as in some product ID. So that is taken as an input in product ID and matched with your database. Whatever the information is, it will be displayed on your screen. Right? So in this way, there's an image which works for only single row of pixels. Now this will be limited, right? Limited for a particular kind of application. So the second type of camera is the area scan. Now, the only difference between these two types of cameras is line scan will have a single row of pixels, whereas area scan will have a matrix of pixels. So there will be rows and columns which will be scanned at the same time. The only difference here is of how the entire grid of image is read, right? In line, it will be reading single row of pixels only, and that will be its output. Now, if you want to store multiple rows of pixels, you have to go for area scan cameras, right? Or during this evolution of area scan cameras, how it was done, multiple rows of pixels were collected together. But here there was some challenge because you need to have a synchronization and the actual value and the position where the pixel is stored to represent an image must be synced, right? So this synchronization of storing from the actual line scan cameras and then showing it as an whole image is nothing but the array of pixels, a matrix of pixels, which is called as area scan cameras. There's also a third type, which we call today as the smart camera, which has an inbuilt image processing capability, right? So it's smart enough to identify where it should be used as line scan cameras, area scan. You may have seen your smartphone cameras, it detects different AI scenes, it detects a room, it detects an object. Even though you pass on the information of barcode or QR code, it can read, it can detect the edges of any object, it can scan your documents, right? No matter it is how it is written, whether it is in a printed form or it is handwritten or any kind of image, any, you can say, invoice, any receipt you want to store it in digital form. Smart cameras can handle all of this because they have a built-in image processing capability. The moment I talk about image processing capabilities, there will be some image processing algorithms inbuilt on that circuit board wherein it allows extra features for a camera, right? So basically, these are two categories, camera types, line scan and area scan. But there's also third one, that is the smart camera, right? So we have a general idea of how these are. Now let's see what are area scan cameras. Area scan cameras are very quick to read and store an image because they have a defined area of an object or a scene, right? So the moment you click that image, the data is automatically stored and the entire area is being scanned. Hmm. Now this happens when we have a large matrix of pixels. The grid must be in terms of rows and columns to store the data, right? Now that pixels in terms of matrix captures a 2D image of a given scene in one exposure. This is very important. If you have multiple exposures using area scan cameras, there will be multiple images. If you capture multiple rows of pixels in one exposure, the multiple rows of those pixels need to be collaborated, need to be synchronized to form one image, right? So here in area scan, the exposure is given to the entire part and within a single glance. Hmm. Whereas in line scan, you need to have it line by line. Hmm. This is how it is read. Now consider this as an image which is being captured using an area scan camera. As per an example, suppose we are having a 1 megapixel camera with a zoom lens which captures the image of the object that appears in its field of view. Within a glance, within its exposure, whatever the area scan cameras can see, that will be exposed to the photovoltaic cells and the image will be captured at a time because there's a matrix, a grid of pixels. Now here, the distance between the camera and the image will determine the field of view. So there must be a sensor which identifies the distance of that image from the camera so that it can determine the actual area which is to be stored, which is also called as field of view. Technically, we call it as field of view. Now, the image quality is best. That is, these parameters are dependent on very much the distance, right? So the image quality of such kind of type of camera is best when the distance is adjusted on the basis of specifications of zooming lens present in the camera. So if you want to capture an imaginary in a scene, it must be a kind of in a panoramic view, right? But the moment you try to zoom it, you will be decreasing the field of view, right? But we'll be getting a high resolution. The object which you're going to see will be nearer to you, right? So we'll be focusing on particular object. So this depends or the distance between the camera and the image will determine the your actual field of view, right? So as the resolution of your camera is fixed to only 1 megapixels, it can be easily installed and aligned to capture an image of the desired object. So it is very easy to understand. So areas wherein we need to have a field of view, area scan cameras are best suited for applications wherein we have can say fixed or stationary objects, right? Even if only momentarily, but the objects where they are fixed and stationary. So we can conclude that from this kind of structure of area scan images, if the object is not moving, we can use area scan cameras. And if the image or the objects are moving, we can go for line scan cameras, right? So let's see the other part of line scan cameras. Hmm. Now, this is a very easy concept as we've seen in the previous images, how lens cameras can work. It will be using a single row of pixel to build a continuous image. The moment it goes under the camera, any object, any image, it starts to read it line by line, right? So the complete image is constructed line by line as the object moves past the camera. Hmm. So here line scan cameras can be best employed in high speed processing because the data has to be read line by line, not the entire field of view. Right? As in we are keeping any object on a fast moving conveyor line applications. This is the actual scenario of line scan camera, as you can say. The moment we fix our cameras in line scan camera, it is very important the coordination of camera motion and the image where from where it will be scanned or it will be moving, the image acquisition timing. Remember these 2 points: coordination of camera motion and image acquisition timing are very critical when using line scan cameras. These are very much important when we talk about line scan. You can see here, line by line, the pictures will be captured here. And then the moment we pass on this image, it moves forward. Every pixel will have its own intensity representing a particular image, right? So these type of cameras can be used to detect defects in continuous material like cloth or steel chain on the production lines. If you remember, I have given you an example in a mechanical industry where we cannot see the edges, or I can say if there's a crack in between a metal sheet, and if it is not being able to identify it by the human eye, line scan cameras can really help us in this kind of scenario to identify those cracks, or if some of the edges are being folded, right, for a metal sheet. So this kind of entire structure to identify the objects and internal and on the edges can be really helped by using line scan cameras. We'll move to this point. Let's have a discussion on this, right? This have a uh, high speed processing because we are going to use it on a moving conveyor line application. So moreover, when we talk about line scan cameras, it could be used to detect the defects for cloth, steel, chain on a particular production line. The most positive point or the advantage here is that the inspected material here can be processed as a continuous stream, right? No matter how many objects you are there, if you are given a static data to identify the object or to find out the defect, if it is not matching with the original pattern, then it will give you a conclusion that so and so object is not up to the mark, and with the along with the product ID, the product can be rejected or might be selected, right? Um, Another classic application where line scan cameras can be used for inspection of the surface of a rotating cylinder, whether the bottles have its caps or not, whether the actual size of cutting of sheets are properly done or not. So there are a lot of applications where line scan cameras can be have. It can have many advantages when compared to area scan cameras. Line scan cameras, whereas uses a single row of pixels to build the image, their resolution is defined by the scanning rate. So if it is low image, the scanning rate will be low. If it is high, it will be uh, for a high resolution, right? Unlike whereas these area scan cameras, the vertical resolution is not limited. Hmm. So it is possible to have higher resolution in both 2D and 3D cameras also. Hmm. Line scan cameras can be used to capture images, you can say, of objects that appear between the rollos on a conveyor. Single line cameras can be used instead of multi-area scan cameras to view the opposite side of the object as the cameras or objects are rotated. Right. So you can have an entire 360-degree view using line scan cameras as well as area scan cameras. Depending on, probably it's very important that these both cameras are really necessary. They have their own pros and cons. But the moment you're using this kind of cameras, you must be very clear what kind of application you're going to use, what is the purpose of your software to identify, to work on with. Depending on these parameters, you need to identify which type of camera, either line scan or area scan, which type of camera we are going to use. So it requires very simple illumination in line scan cameras compared to area scan. Now, despite of having these number of advantages, there are, you can say, many reservations about deploying line scan cameras because of their higher cost. Now, the line scan camera is perceived to have complex because it will be scanning the moving objects. It must have higher FPS, a higher resolution to store, faster compared to area scan, because in area scan cameras, the object will never move. Moreover, the camera may move, but at a particular fixed location only we are going to click it. Otherwise, we keep it in motion. The moment we click at any certain instance, the image will be anyhow captured, whether it is blurred or very good. But in line scan cameras, there is 100% probability that if you're using TDI sensors along with, the camera will move with the object, but the assurity is that the object will be moving on, right? So there's no, you can say, static object where you need to just capture it. It will be in a moving continuous form, right? So it is complex, and because of its precision in timing, even though the objects are moving, it has a very good precision in timing and coordination, which is required for acquiring accurate images. So line scan cameras are very fast compared to area scan cameras. But again, I'm saying depending on what type of application you are going to use by using these type of cameras is very much uh, necessary. It Next, as I said, the point for smart cameras. This is very, I can say, good part. Smart cameras nowadays are designed for specific purposes, right? Most of the users, while selecting their mobile devices, probably based on any other feature, are moreover concerned about the camera type, right? How and what different features does it have? Most of the time, a non-technical user, the end user, is unaware of the image processing softwares which are being applied to the camera, the default camera. It can detect your face, multiple faces. After storing the digital image, you can render it in any type. It is able to identify each and every aspect of your face, and by different settings you can change the entire structure of that face also. So the specific purposes what we can define for smart cameras is to detect motion, right? This is a very image stabilization. Even though your device is moving while capturing the image, it will be having a stability so that your image will not be blurred. Then to read part numbers, to detect vehicle plates, right? This is, you can say, again one type of very good application. It can be used on any, you can say, tool center wherein the cars will be moving and we need to detect the entire image in a single instance in one exposure, try to identify the car, then its number plate, and then try to read the numbers. And on the other hand, we can have access to that car's information, and we can drop a message that this much amount will be directed as toll pass from this area to this location, uh, from to the user. There might be video surveillance also. There are many industrial applications, robotics performing different operations, different tasks automatically in real time. And obviously, the moment we talk about real time, there are games involved here also, right? So smart cameras, you can say this, what today we are using is the light, the camera, whatever the object is in real time. There's a system called as embedded system where we have all of those circuitries, the lens adjustment, the autofocus, the image processing softwares, different algorithms. different filters, different techniques, everything will be applied into this embedded system, and accordingly what type of device we are using, uh, what type of device we are using will be having the camera type, right? So smart cameras basically uses embedded systems for image processing, and these are very much reliable, right? In terms of industrial applications, based on, might be there are some conditions, atmospheric conditions such as heat, dust, depending on the ambient light. Even though in this scenario, if they have given as lightning, even if this lightning is low or too much exposure is there, the automatic adjustments can be done via that embedded system, where different applications are there to reduce or increase or decrease the exposure of light so that you can get the actual. This can be manually done also, and also the softwares can identify whether a particular image clicked in a low light must have some brighter pixels to be included into it. So accordingly, and vice versa, these applications will anyhow help you to get a more clearer, sharper image so that it will be stored well in terms of image processing. So see, there are different softwares which will help you to increase the machine vision, right? As in smart cameras, we have two different steps of image of acquiring an image. The first is the image acquisition, the way we capture the images is, and second is the image processing. Before it is being displayed on your output screen, the captured image passes through an embedded system where it identifies that whether this image is a good quality image or not. If it is not, some filters can automatically be applied or can be asked to the user to change so that they might get a better mm, field of view of that image. Now, there are very much concepts and algorithms going on in the image processing, can say, with industry perspective. As here, smart cameras are designed for specific applications. It may not always be possible to get smart cameras that will be suitable for your requirements, but smart cameras are becoming very much popular because they're easy to use, they're very handy, and now they are being designed to work for many standard applications. So it is not static, as line scan cameras are only used for some specific applications. Now both area scan as well as line scan and all those three sensors are being embedded into your smart cameras. No matter what the field of view is, depending on the field of view, the image sensors will be able to recognize what should be done, what should be the input for processing. If I click an image of a QR code and pass it to my image processing algorithm, it will be able to identify that this image is a type of, you can say, a QR code or a barcode. Even though if I take a snapshot of my screen and store it, it is able to identify that this is a mobile screen and this must be stored in a screenshot folder rather than in the camera, right? So it also detects documents from a set of bunch of, it is able to identify different objects, right? So identification of all these compared to any of industrial applications, your daily work, your household appliances, object detection, anything is done through embedded systems. So this is a very essential part of understanding of how smart cameras will work. Now this logic again be briefly described in this camera part. Now this camera is very smart nowadays. It occupies very less space. Most of the things are dependent on embedded systems. Lens adjustments in these cameras provide a higher resolution, more accurate. You can even click images in low light images also, even in there's a filter as night mode. So it, the moment it is on, the circuit, the camera gets to know that the images will be clicked in a dark area, and while clicking the image, the exposure must be increased so as to capture the image as it looks in the original way, right? So there are many algorithms which are working in the backend via the embedded systems so that your images during exposure will be captured the way they are. Hmm? Okay, so today we'll stop here. I'll be marking the attendance for two lectures, and one lecture we will try to cover this in this week itself, right? In next lecture, we are going to see the different types of camera lenses, their adjustments, how they are done, and with those different types of lenses, how we can identify the focal length, because that distance will give you the actual resolution for your image, right? So we'll have that perspective and aspect of using different lenses in the camera to pass on image to the embedded system so that it can be able to recognize and process the images in different perspectives. So as the sessions is being recorded, you can, yes, very good. Sikandar, you can type your roll number and name in the chat box. If you have dropped it in the chat box, you can leave the meeting. Those who have not dropped the message in the chat box, drop it, because the session after 2 to 3 minutes will be automatically logged out. Okay, I hope everyone have posted their roll numbers and name in the chat box to record their attendance. Okay, I'll end the session here.